Okay, so we're reviewing for test 2. Okay, and so everybody should have a review sheet in front of them. Okay, write the word or phrase that best completes each statement. Okay, so basically here we want to know what is the transformation that's taking place. So let's review that real quick. If we have, and since we've been working with parabolas, we'll use a parabola here. Actually, this test covers the library of functions, but we'll go ahead and work with parabolas right now. Okay, so we have here y equals to f of x plus k. So this is going to make the graph do what? Move up, down, right, or left? Yeah, it's going to shift up k units, and so that would make this shift down k units. Now if it's k is inside the parentheses like this, yeah, left, it's going to shift left k units. Very good. And so it's the opposite inside the parentheses, right? So if it's x minus k, it's going to shift right k units. And if we have a times a function such as y equal to 2x squared, right? What's this going to make it do? Yeah, it's going to stretch, vertically stretch in this a units. So if it's a fraction, right, it's actually going to flatten it out, right, or compress it. And then if we have a negative, what's that going to do? A negative outside. Yeah, flip it, right? Also known as reflect, about the x-axis. So what was open up is now open down, and so on. Okay? Okay, so let's take a look at our review sheet. So this made it shift to the right. So that means, and what kind of graph, you have to look at, you know, which parent graph are we talking about here? So it has an endpoint to it, right, and it goes up and to the right. So what is that? Is it a parabola? Is it cubic? Is it a square root? Square root, right? It's a square root. So we can start off by saying, all right, I know that this is a square root. And so y equals to the square root of x, and it's going to start off up and to the right. Okay? Okay, that's a new one. So it's going to start up and to the right. And since this graph here is shifting right, then we're going to take our parent graph, right, and we're going to make it, and so this shifts one space, right, to the right. So that means the 1, is that going to be outside? Like, yeah, it's going to be inside. Y equals to the square root of x. And is it going to be a plus 1 or a minus 1? Minus 1. Good. It's not this, because this is up here, right? So, all right, good. Any questions with that? All right, so that's a review of our transformations. Okay, now this one here, write the equation of the function that has the given characteristics. We have, what do we have here? Y equals 2, and we got an x in between two bars. So what kind of function is that? Yeah, absolute value, right? And it looks like a v. Good. So we know that it looks like a v. And so we want to write the equation to that function. Okay, so it shifts 5 units to the left. So is that 5, is that going to be inside of the absolute value with x, or is it going to be outside? Yeah, it's going to be inside. And it's going to be shift to the left. So is that going to be a plus or a minus? It's going to be it's going to shift to the left. So remember now it's opposite. Shift left. So, and this is 5, so if it shifts left, remember now this shifted to the right and it was a minus. So this shifts to the left. And so that's going to be a plus. It's opposite inside the parentheses. When it shifts right or left, it's opposite of the sign. Okay? Questions there? Alrighty. Okay, so the answer here is the equation. Okay? And I just drew it just to get a better picture of what we have, but you won't have to graph it. You'll just have to write out the equation. Okay. Any questions with number 2? All right. Do we have any questions with 3? Graph shifted 7 units up. I think that's pretty much self-explanatory. So I'm going to ask if there's any questions. If you don't have any questions, we're going to move on. So please, this is the time to ask questions. That's why we're doing this. So if you have questions, ask. Okay. Okay. Graph. So we graph a function sharing the graph of a basic function using techniques of shifting, compressing, stretching, and or reflecting. So here we have an x cubed minus 3. So we want to look at the parent graph, right? So the parent graph, what's that going to look like? Yeah, it's going to be up and to the right and down and to the left. So it's like a parabola that has half up and half down, right? So you start with the parent graph, y equals x cubed, and that's half, like a parabola, half up and half down, where this point here is known as the point of inflection, where it goes from curving up to curving down. So we're going to take x cubed minus 3, right? And we're going to shift it which way? Down 3. So this point here is going to go down 1, 2, 3. So this point is now down here. So now it's going to move up and to the right, down and to the left, like that. Okay? And so you just got to select the correct graph there. Okay. Moving right along. Okay, now this has got a couple of things going on. Any questions here? Do you need to see that one? Yeah, okay. All right. So what kind of parent, we look at the parent graph first, right? What kind of parent graph are we looking at? Y equals what? Yeah, 1 over x. Y equals to 1 over x. And y equals to 1 over x has what in it? So this will be y equals to 1 over x plus 3 and then minus 2. Okay, so this is what we've got, and we want to graph that. So what do we call these in the parent graph? These dotted lines. Yeah, asymptotes, right? We call them asymptotes. That's an arrow there. This is an arrow here. So that graph is going to ride along that asymptote. It's going to ride along there and ride along there, and it's like it's hugging. It wants to go to that. It wants to tend to those asymptotes. Going to the right is going to get closer and closer. To the left is going to get closer and closer to the vertical. And then the other side is going to get closer and closer to the vertical, and then the left is going to get closer and closer to the horizontal that way. And they're going to go on forever, right? To infinity. Okay, so that's our parent graph. So now we have to look at what is this graph doing? What shift is taking place? Let's look at the denominator first. Now this is like parentheses, right, in the denominator. So that makes it shift 3 spaces to the what? To the left. Shift left. 3. And I would write that down. And the 2, that's going to make it shift which way? If it's outside, if it's inside the parentheses, it's going to shift right or left. If it's outside of the parentheses, it's going to shift up or down. Down, yes. And down. 2. Okay, so, all right, so the first thing you want to do is shift what? Yeah, the asymptotes. You want to shift the asymptotes, and then the curve will follow, right? So it's going to shift left 3, 1, 2, left 3. So that's negative 3, and so that's our vertical asymptote, and a shift down 2, down 1, negative 2, and then our horizontal asymptote shifted down 2. So that curve is just going to hug those asymptotes. Wherever they go, the curve follows. Okay? And so this point right here, the crisscross, right? This point here was started at the origin, and now that point has shifted left 3 and down 2, and so the curve just follows that. And that's our graph. All right, questions there? Alrighty. Okay, moving right along. Okay, the graph, y equals x squared, vertically stretched by a factor of 2. So where's that 2 going to go? Yeah, it's going to go in front. So it's going to be y equals to 2x squared. Okay, so if you're looking at, so it's going to be y equals to 2x squared. So the parent graph starts off at 1, 1, right? And negative 1, 1. Because when x is 1, 1 squared is 1, right? So, but with y equals to 2x squared, now it's at 1, 2. And negative 1, 2. So it stretched the distance from the x-axis to the curve. It stretched it, okay, by a factor of whatever this number is, okay? So if it's a fraction, right, instead of 1, 1, 1, it's going to be 1, whatever the fraction is, right? Like if if this is 1/2 here, then it's going to be 1/1/2. And it's going to flatten it, make it flatter, right? So that's known as vertical compression. Okay. All right. So that's different than if it was plus, right, or minus, because then here the 2 is multiplied, right? Here the 2 is multiplied into it. It's not plus or minus. If it was this, if it was y equal to 2 plus x squared, now that's shifted up. But it's not a plus, it's times. See the difference? Okay, so sometimes people tend to get, in math you have to pay close attention to the particulars, the details. Okay. Find the function that finally graph after. Do we need to see 7? Find the function that you start with your absolute value, right? And then you shift it right 3 and stretch it factor 3 and vertically down. Do we need to see how to write that? Or are we good there? Do we need to see number 7? No? Okay. All right. Yeah? Yeah? Okay. All right. So basically, it helps to write down and scratch a paper. You've got, this is 7. You've got y equals 2 the absolute value of x. And so we're going to shift right 3 time, stretch it by a factor of 3 and down 2. Okay, so this is our scratch paper, right? So we're going to shift it right. So here's our absolute value, right? We know we're going to have something inside, something outside. So we're going to shift it right 3. So where's this 3 going to go? Is it going to go inside or outside of the absolute value? Inside. Yeah, it's going to be inside because it's right. And because it's right, is it going to be plus or minus? Minus, because it's opposite inside, right? Now it's going to multiply by a factor of 3. So where's this 3 going to go? In front, right? It's going to multiply it times. So that's times 3 times the absolute value, right? And then it's going to shift it down. Yeah, that's going to be outside, and that's going to be plus or minus 2. Minus 2. And that's our answer. Okay? What? Oh, reflect. Oh, I missed that one. Okay, so reflect over the x-axis. Yeah, so that'll be negative. So we'll put a negative in front of that 3. Okay, thank you for that. Any questions there? Alrighty. Number 8. So this is basically the same thing, only now we're using square root. So do we need to see that one, or 7 was actually harder, right? 7 actually had more transformations than 8. Okay, determine the slope and the y-intercept. We need to see 9. Are we good with 9? We're straight. Okay, so basically you're using y plus mx plus b, right? Okay, use slope and y-intercept to graph. So again, any questions there? Do we need to go over that one? Okay. What? We're good. Okay. Determine the average rate of change. Number 11. Okay, average rate of change. All right, number 11. We have We want the average rate of change. Okay, and we've got f of x equals to 1/2 x plus 1. Okay, so here's our board. Okay, now average rate of change is really nothing more than slope. Average rate of change is nothing more than slope. So if we're looking at y equals to mx plus b, our average rate of change, and we use the delta symbol for change, because that's what change is, delta, right? Difference. Change is difference, and this time in x. Average rate of change for this equation would be what? Yeah, it's 1/2. It's nothing more than the slope. Okay, and that's our answer. Alrighty? And that's just all there is. There's nothing to figure out there. It's just extracting the slope from the equation. Alright? Questions there? Okay, so what about 12? What would that be? -1, yeah, good. Okay, graph the function, state whether it's increasing, decreasing, or constant. We need to go over that? Or are we good there? Go over it? Okay. All right, no problem. All right, so we have here p of x instead of f of x, but that doesn't matter because that's like the name for the function, right? It just doesn't. It doesn't matter if it's p of x or f of x. It's just indicating that it's a function. Okay, so basically we start with